Hey everyone, let's jump right into this. Welcome to today's Explainer, where we're embarking on a genuinely fascinating journey to uncover the hidden superpowers of language analytics. If you've ever spent hours, and I mean hours, poring over texts, trying to decode exactly how and why a piece of writing works, you are definitely in the right place. Right now, applied linguistics is colliding head-on with raw computational power, and it is completely transforming how we analyze written and spoken discourse.
Seriously, think about this for just a second. What if you could read and analyze a million student essays in a single second? I mean, for any educator who has ever felt the sheer, soul-crushing exhaustion of manual grading, carrying home those massive stacks of papers on a Friday night, this probably sounds like science fiction. But we're actually right in the middle of a massive paradigm shift.
So let's get into Section 1, the Analytics Revolution, a paradigm shift.
There is a dramatic contrast in scale happening right now, and it's literally night and day. Traditional text analysis relies on this old world of neon highlighters, manual tally sheets, and maybe, if you're lucky, analyzing 20 student essays at a time. It leans incredibly heavy on manual coding and, let's be honest, subjective interpretation. But advanced language analytics? That moves us away from the red pen and into algorithmic parsing. We're now processing massive digital corpora, literally millions of words across thousands of texts, using statistical indexing and empirical pattern recognition to find things that the human eye simply cannot see.
So how do we actually pull this off? Well, we need a brand new toolkit. Programs like AntConc, Sketch Engine, Voyant Tools, Cometrics, and Python using the Natural Language Toolkit are the engines powering this revolution. Think of these as the ultimate utility belt for the modern English educator, allowing us to move way beyond manual close reading to uncover tiny, microscopic patterns in grammar, vocabulary, tone, and syntax.
Moving right along to Section 2, Supercharging Language Analysis, Techniques.
Okay, first up on the docket is corpus linguistics and concordance analysis. Sounds a bit dense, right? But instead of looking at isolated, totally artificial grammar rules on a whiteboard, massive digital text collections allow us to see how words actually live, breathe, and interact together in the wild. By tracking word frequencies, collocations, and keyness, we reveal the empirical reality of how language usage shifts across different genres, time periods, or even learner proficiency levels.
And this builds perfectly into a concept called distant reading. I absolutely love this idea. Instead of traditional close reading where you zoom way in on a single paragraph, distant reading uses computational algorithms to zoom way out. By analyzing thousands of historical texts or essays simultaneously, we expose these massive macro-level stylistic, structural, and thematic shifts that are completely invisible when you're just reading one page at a time. It's like stepping back to see the entire mosaic instead of just one tile.
You might be wondering, what else can we actually measure here? Well, the advanced analytical techniques are incredibly robust. With automated sentiment and tone mining, natural language processing algorithms parse vocabulary to classify emotional valence, basically figuring out if a text is positive, negative, or neutral. Then you have computational stylometrics, which tracks sentence length distribution and vocabulary richness to do things like verify authorship or even detect plagiarism. And readability analytics, using tools like Cometrics, can objectively evaluate deep cohesion and cognitive processing difficulty, which takes us way beyond those basic, old-school readability formulas.
Which brings us to Section 3, Theory meets Practice, Applications.
Look, I want to be clear. This is not just tech for the sake of tech. These tools are bridging computational linguistics directly with foundational educational theories, like systemic functional linguistics and cognitive linguistics. And there are some seriously powerful real-world applications here. First, data-driven learning turns ESL students into actual text detectives, having them discover authentic usage directly from real-world corpora rather than memorizing artificial textbook rules. Second, diagnostic writing analytics parses learner texts for syntactic complexity to objectively identify exactly where a student is hitting a developmental writing plateau. And third, textbook alignment lets educators verify if reading materials actually match targeted cognitive readability standards like CEFR or Lexile levels before those books ever reach the classroom.
Let's make this super concrete with Section 4, Syntactic Growth, a Case Study. You know how traditional holistic grading can kind of miss those really subtle structural changes in a student's syntax? Well, when you map it out, a computational framework changes all of that. Check out this pipeline. For the input, we start with a baseline corpus of 60 argumentative essays from grade 11 ESL students. Then, the process, an 8-week writing module focused on data-driven, corpus-informed syntactic instruction. And finally, the output.
It isn't just a subjective letter grade at the top of the page. It's a set of exact quantitative metrics generated by an automated syntactic complexity analyzer.
So what exactly are those metrics? Well, these are our dependent variables. We're effectively replacing vague, holistic grading vibes with precise structural shifts. We are measuring the mean length of sentence, the mean length of T-unit, the clauses per T-unit, which acts as a subordination index, and the complex T-unit ratio. Because under theories from systemic functional linguistics, advanced language development is marked by this increase in clausal density and embedding, not just mashing words together to make sentences longer.
To extract all those specific metrics, this study leans on some serious powerhouse tools. The L2 Syntactic Complexity Analyzer, or L2SCA, extracts 14 distinct syntactic indices straight from plain text files. Cometrics 3.0 is brought in to verify deep cohesion markers. And finally, open-source statistical packages like Jamovi or JASP are used to run inferential data analysis on those extracted numbers.
When you put it all together in practice, it creates this seamless operational pipeline. Step 1 is sanitization, basically stripping away all the messy, raw formatting to get pure, readable text. Step 2 is extraction, pushing tens of thousands of words through the L2SCA to generate numerical values for every single essay. Step 3 is testing, running paired samples t-tests to measure if the instruction actually caused statistically significant growth. And finally, analysis. A qualitative close reading of the top and bottom 10% outlier essays reveals how those cold, automated metrics actually manifest in real student writing.
All right, let's zoom back out for Section 5, expanding the blueprint, more applications.
Here's another amazing application, tackling curriculum alignment. We've all been there, assigning a textbook passage just because a publisher claimed it was grade-level appropriate, which almost always leads to massive reading comprehension plateaus. But by using AndConc for vocabulary profiles and readability analyzers for cognitive load, teachers can now empirically prove if a publisher's textbook actually matches a 10th grader's true reading capacity against national benchmarks.
And how about this one? Online discussion boards. Instructors literally struggle to manually track large volumes of student interactions. By using automated sentiment parsing with tools like Vader or Voyant tools, an instructor can evaluate in real time whether thousands of peer reviews are actually constructive or if the emotional valence is just overly defensive. It scales the teacher's oversight instantly.
But let's pause for a second. Section 6, the human element, critical limits.
Because you have to ask yourself, can a machine actually understand irony or deep cultural nuance? Yeah, the short answer is absolutely no. This is a critical narrative speed bump for us. For all their incredible power and scale, algorithms are fundamentally blind to human context.
And that's exactly why we need to talk about these critical caveats and boundaries. First up is the decontextualization trap. Software counts frequencies beautifully, but it completely misses rhetorical intent. You still need a qualitative human eye to validate what the numbers actually mean. Second is algorithmic bias. This is a strict methodological limitation. NLP tools are often trained on standardized native speaker datasets, which means they might unfairly misclassify regional dialects, like World Englishes, as erroneous. You have to evaluate the scoring critically to ensure fairness. And third is methodological balance. Close reading isn't dead. It's required to validate the quantitative outputs.
Which all boils down to this one core philosophy. And if you take away nothing else from this explainer, remember this. Analytics tools generate metrics, not research insight. A strong research project or curriculum update uses computational tools to answer a theoretically grounded research question. You can't just pick a topic because a fancy piece of software happens to exist. The machine gives you the numbers, sure, but the educator must provide the insight.
And that is the ultimate takeaway here. The goal is absolutely never to replace the teacher with an algorithm. The goal is empowerment. By combining the massive macro-level processing power of computational linguistics with the deep qualitative expertise of an educator, we unlock a whole new dimension of understanding. So I'll leave you with this final thought to chew on. Are you ready to use advanced analytics not to replace your teaching, but to give it a superpower? Thanks so much for joining me on this deep dive, and I highly encourage you to start exploring how computational linguistics can elevate your own work.